Hello students, welcome to this lecture in which we're going to talk about triple integral over non-rectangular region. So the example of this would be find the volume of tetrahedron with corners at the origin, then 0, 3, 0, which is on the y-axis, then 2, 3, and 5, and the last one is 2, 3, and 0. So let's try to visualize this picture. So we have our axis, and let's put the points in. One is at the origin over here. One is on the y-axis over here, which is 0, 3, and 0. One is over here, which is 2, 3, and 0. Right? So 2 along the x, 3 along the y, and one is at 2, 3, and 5. So basically, if we connect these points, doesn't want to do that. All right. So if we connect these points, we get our tetrahedron, and we would like to find the volume of this tetrahedron. So how we're going to approach it? We're going to get volume. We're going to get the volume by computing hypervolume which is basically a triple integral of x, y, and z dv over some region where f of x, y, and z, since we can set it equal to 1, and this is usually called characteristic function. So characteristic function of tetrahedron. So we only need to figure out the description of this tetrahedron. So we need to find a good description of the tetrahedron. Okay, so let's start slowly. So we see that x goes up to 2 because that's the farthest x goes. So let x be between 0 and 2. then in the xy plane we get, so basically xy plane on the bottom we get the picture like this. So we have this red line over here, let's call it line number 1. So line number 1 goes like this, and then this line number 2 goes over here. All right. So let's try to understand. Sorry, this is y and this is x. So on the x-axis we go up to 2, and on the y-axis we go up to 3. So this point has coordinates 2, 3. So the slope of this line is the change in y over the change in x, and change in y is 3, change in x is 2, so our y is equal to 3 over 2x. Since it goes through the 0, 0, through the origin, there is no y-intercept. So we can say that as x goes from 0 to 2, y goes from 3 over 2x to 3. All right. So x goes from 3 over 2x to 3. All right. Then we move to the xz plane. In the xz plane, what do we have as a picture? In xz plane, we have something like this. So we have our line sticking out like this, and it goes up to 5. So on the x-axis it's up to 2, on the z-axis it's up to 5. So this point is described by 2, 5. Maybe we'll make this dotted line here. Okay, dot, 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 dot. So what does it mean for us? That means that z is 5 over 2x. Again, the slope is 5 over 2 and goes through the origin. So that's what happens here. So on this axis, as x goes from 0 to 2, z goes from 0 to 5 over 2x. 5 over 2x. So now we can set up our volume. So we have volume equals integral, integral, and integral. And we start with z. So z goes from 0 to 5 over 2x 1 dz. Then we go into the y-axis, and y changes from 3 over 2x to 3. From 3 over 2x to 3. And the last one is for the x, and x changes from 0 to 2. So this is dy dx. All right. So then we just integrate, but that's kind of a straightforward procedure. So we integrate 1 with respect to z, so it's going to be integral from 0 to 2, integral from 0, well, not 0, but 3 over 2x to 3 of z evaluated from 0 to 5 over 2x dy dx. And when we plug in 5 over 2x, we get it, but when we plug in 0, it's going to be 0. So it's a double integral from 0 to 2, from 3 over 2x to 3, or 5 over 2x, 5 over 2x dy dx, dy dx. So we move forward, we integrate it with respect to y, so we're going to get the integral from 0 to 2, 5 over 2 xy, evaluated from 3 over 2x to 3 dx. So we plug it in, so we're going to get the integral from 0 to 2, 3 times 2 is 5, so it's 15 over 4, 15 over 4 15 over 2 x minus 15 over 4 x squared, right, dx. And then we integrate it further to get 15x squared over 4 minus 30x cubed over 12 from 0 to 2. Right. Okay. All right. So this is fine. And did I do it right? Oh yeah, this is wrong. Should be 15 over 12. So we can divide by 3. So it's going to be 5 over 4. 5 over 4. All right. So we plug in 2. So we're going to get 4, so it's going to be 15 minus, we plug in 2, so it's going to be 8, so it's going to be 10, and then we plug in 0, which is 0, so we're going to get a volume of 5. And that concludes this lecture.